Okay, so if you are gone today, it is Friday, January 29th, and we have this slide up, and if you want to look at it, you'll be pausing it. I'll just talk about it very briefly. Yesterday, as you know, we converted from logarithmic to exponential form back and forth. We just said that a logarithmic function is the inverse of the exponential function. You might want to sketch a picture of this, write whatever you think is appropriate from this piece of information. And then down at the bottom, I'll just read that. The statement above indicates that the log base b of x is the exponent to which b must be raised in order to obtain x. Therefore, when evaluating logarithms, remember that, oh, a logarithm is an exponent. So we should probably have that written in our notes just as a reminder. And then today we're going to just convert back and forth from logarithmic form to exponential form. We already kind of had our introductory thing because a lot of people are gone in this already. So 1a is the log base 2 of 16. I'm going to tell you, especially starting to learn logarithms, you know what? You want to say is equal to, I don't know what I have called it, y. The log base 2 of 16 equals y. And actually, let me just say, this was originally the log base 2 of 16. That's what the book authors will give you. And so if you rewrite it like this, then you're going to remember our base is 2. The logarithm is equal to the exponent, so 2 to the y equals 16. So you can convert that into exponential form. Now, the deal with logarithms is when you have a little equation like this, if the base here is 2, you want that base to be 2 as well. And 16 should be recognizable as something, 2 to the something. And if maybe this would have been 4, well, 16 would work. Or then even if this was 4, I could change this to 4 squared, right? So they would be the same. Or I could change them both to 2. And so sometimes, you know, if this was 25 over there, one side, and 5 on the other side, we want to change them to a common base. So I want to change 16 into 2 to something. 16 is 2 to the what? 2 to the 4th. So 2 to the y equals 2 to the 4th. And then this is my method. I'm going to go away from this, and this is just a matching thing then. If this is 2, these bases are the same, and that's 2, then these exponents have to be the same, and it's y equals 4. I usually draw a little dashed line for myself. That means I'm moving away from the original equation, and I'm setting some pieces equal to each other as I go. So let's look at a couple more of these things. So our next one, 1b, is the log base 5 of 1 over 125. And so then I'm going to rewrite it just so we know that's what I'm going to see. The log base 5 of 1 over 125 equals y. And as you get better at it, you might drop that, but certainly right now, that will give you a very nice comfort level. And now I write it in exponential form. The logarithm is the exponent. The base is down here. 5 to the y equals 1 over 125. Now, 125 is 5 to the what? 5 to the 3rd. So 5 to the y equals 1 over 5 to the 3rd. And do you agree that if it's 1 over 5 to the 3rd, that's the same as 5 to the negative 3? Will you give me a quick head nod for those of you in the room? Just want to make sure that we're good to go on that, 5 to the negative 3. And then again, once I have my bases the same, since they're equal, then my exponents have to be the same. Y equals negative 3 for that one. So that's the straightforward problem. And most of these that we'll encounter right away are pretty straightforward. The next one is one that is just like the last one. So why don't you try this one? So 1c is log base 3 of 1 over 27. Are you ready? What is it? -3. And so there it is. So I'll just kind of turn everything into purple. Very similar to that previous one. This next one I want you to take special note of. And we're going to add to this one a little bit. So this is the log base 17 of 17. And so I'm going to say the log base 17 of 17 equals y. And a little bit before I started recording, maybe we had talked about a couple of these when we were talking about the calculator. Does anybody know what log base 17 of 17 is? 1. And so think about what that is. That is 17. This base is the 17 raised to the exponent y is equal to the answer, which is 17. And so that 17 is like 17 to the 1, so y equals 1. So comparably, let me ask you like 3 quick questions. What's the log base 12 of 12? 1. The log base 20 of 20. The log, base E of E, 1. And really, we haven't covered how to write that. That's not really how we will write the log base E, but if we write it that way right now, it'll give us that idea of what we're looking at. So I think that's pretty straightforward. Now we have to talk about properties of logarithms. So the one we just looked at is this second one right here. And for those of you in the room, I do sometimes point to things. So since I'm recording this, I'm going to start underlining things in yellow. Do you agree that's the rule we just looked at a moment ago? So the log base b of b equals 1. You want to remember that, but if you forget, you can always figure it out, correct? Because you'll say b to the what equals b. Well, it's 1. And now look at the one above it. Every once in a while I get that little thing. The log base b of 1 equals 0. Let's kind of just do a problem like that to get that in our mind. So the log base 4 of 1 equals y. That means 4 to the y equals 1. Well, to get 1, we take 4 to the what power? 0. Anything to the 0 is equal to 1. So 4 to the y equals 4 to the 0, and that's why y equals 0 here. And so then we can say that is 0. So when we look at this first rule, and again, if you forget the rules, you know, it's great to remember the rules, but it's a lot to remember. If you forget it, you can always write it out as an exponent and figure out what it is. So the log base anything of 1 equals 0 because anything to the 0 power equals 1. So take a few minutes and write these basic properties. The log base b of 1 is 0, and b can be any number then. The log base b of b is 1. These next two that are called inverse properties, we'll kind of just look at an example of those as well. First, let's look at this one, and I'll erase these when I'm done. But it's the log, let's pick a base. Log base 2 of 2 to the x equals, let's say I don't know what it is. I'll say it's y. Then if I write that in exponential form, I get 2 to the, 2 is this base down here, 2 to the exponent y equals 2 to the x. Well, if these are equal, then y equals x. So I can replace that y equals x. And I can replace that y with x. So log base 2 of 2 to the x equals x. So it kind of is just really saying that you're taking that to the same power either way. Do you agree that those first 3 things are written as logarithms, correct? Do you agree that the fourth one is written as an exponent in exponential form, right? Because this is b raised to a power equals an answer. So this one is an exponential form, and I'm going to write it like this, still general. B to the log base b of x. By the way, it gets a little smush to write all these. Do you know what I mean? Because this is a b, this is a power, and this is a subscript. So it does get a little bit messy there. if I were going to write this, this is an exponential form. Do you agree? So it's a number raised to a power equals the answer, right? So the base raised to the exponent equals the answer. So if I change this to logarithmic form, it's the log. Which one of those is the base? B, right? The log of B, or log base B, excuse me, I didn't write it as the base then. The log base B of the answer equals, the logarithm is equal to the what? No, wait, what's a logarithm? Exponent. The logarithm is equal to the exponent. So this is the log base B of the answer equals the exponent. So isn't that nifty, kind of? That's a little tricky to kind of wrap your head around the first time, maybe. But that's saying, so I'm just going to highlight the different parts here in different colors. So this was our base raised to our power equals x at the top. And then on the bottom, it's our log base b of, and I usually say the answer. This is the answer of that exponential problem, is equal to the exponent. And now the exponent is that log base b of x. I write that log base b of x right here. And then when you look at that, is that just something that's true, right? Because it's identical on both sides. And you'll find then, let's use a number example. So 3 to the log base 3 of x. And suppose I'm asked to figure out what that is. Well, suppose I don't know what that is, right? Because I'm thinking tomorrow I look at that and I don't even know what it is. Do you agree with that? Like, if you looked at that tomorrow, you might be like, not sure, don't know. So then if I look at that, 3 to the log base 3 of x, 3 to the log base 3 of x, you need some strategies. So here's a strategy. That's an exponential form. Does everybody agree with that? Because it's a little tricky because it has the word log in it, but it is an exponential form. So this is something raised to a power equals, set it equal to any letter. I'm going to pick n now just to be different. Now, when I write it in exponential form, it looks like that. Then I'm going to change it to logarithmic form and use that as a process all the time. If it's in logarithmic form, you change it to exponential form. If it's in exponential form, you change it to logarithmic form. So this is an exponential form. I'm going to convert it into a logarithm. So I'm going to say log base 3, that's the base, of the answer, this is the answer on this one, equals the exponent. Because a logarithm is an? So I know where that's going to go, right here. Log base 3 of x. So what does n have to equal? N has to equal x. So n equals x. I'm going to tell you right now, because this is very new. I know it's very new, but if you just can get that format down of exponential form and logarithmic form and just knowing to do that. And by the way, I'm gonna clone that if I can. Yeah. And I'm going to tell you that the book authors are just writing that. Okay? They're not going to say it's equal to anything. They're just going to say, figure out what that is. Okay, so you have to remember to, if it's an exponential form, just set it equal to anything and then rewrite it as a logarithm. So that's kind of a big hint. Same with all of these. If it's a logarithm, write it as an exponent and see what happens. If you haven't had a chance to write down what these basic properties are, take a minute and do that right now. And I'll just read through them again to give people in the room time. If b is greater than 0 and b does not equal 1 and x is a real number, then the following statements are true. The log base b of 1 is 0. The log base b of b is 1. The log base b of b to the x is x. And the log base b and b raised to the log base b of x is equal to x. And there is a little disclaimer on that one that x has to be greater than 0. And we'll talk a little more about that later. But right now we just want to get that formatting down. Does anybody in the room need to see this anymore? Okay, then if you need to look at it a little more, you can. Now, my guess is you don't know these by heart yet, or whatever. So if we're not sure, we can always write them in exponential or logarithmic form to kind of figure out what the answer is. So here's number 2a, evaluate the log base 8 of 512. So there's more than one way to do this. One way is to take the log base 8 of 512 and set it equal to y or x or whatever you want to call it, and then write it in exponential form. So what's the base? 8. What's the exponent? Y equals, what's the answer? 512. So now I have to ask myself, can I raise 8 to a power and get 512? So check that out. Or, should I change 8 into something else? 8 to the third. So could I have changed this to 2 as well? And it would just be a higher power there. Yes, that is true. So, but I tried 8. 8 to the y equals, that's 8 to the 3, correct? Okay, and then I can just say, oh, look, y is equal to 3. And to me, that's a pretty legitimate way to go. Now, the next one, I almost feel like if you remember it, it's kind of like, might seem like a trick to you. So if you remember it, I'll ask in a moment, but then we'll actually figure it out a little longhand. So 2b is 22 to the log base 22 of 15.2. So at first glance, it looks like a lot of things there. Does anybody remember what that's going to equal? 15.2, okay? So the answer is going to be 15.2, but I want to take a minute and look at it. And so I'm going to rewrite it as 22 log base 22 of 15.2. Oh, and here's why. Because we said this is 15.2, but again, if you look at this Monday morning or something, are you going to remember that rule? Maybe not yet at this point. So let's just say that's equal to y. So my base is 22, my exponent is that log base 22 of 15.2, and my answer is y. Let's write it in logarithmic form, because do you agree this is exponential form? Logarithmic form, log base, what's the base? Say it. 22 of the answer, y, equals, what's the exponent? That whole thing, correct? So log base 22 of 15.2. So then it's just matching, right? So in a way, you should be noticing this. Yes, it's hard, but if I can remember these formats and kind of change it from one to the other, a lot of times it is just matching. So then I can say, oh, look, the y, these are equal. The only thing different over here is y and 15.2. So then our y equals 15.2. Otherwise, if you remember the law or the what were they called? Property, then you could just say, oh, that's 15.2. And everybody knows that's 15.2. So look at that one. What's the answer? 4. Okay. Oh, okay. Wow. Okay, so now we're going to talk base 10 logarithms, and base 10 logarithms are called the common logarithm. And so now think about these properties, and does this make sense? The log base 10 of 1 equals 0, because 10 to the 0 equals 1, right? And 10, because it's not written here anymore, 10 to the 1 equals 10. And 10 to the x equals 10 to the x. Okay, so this you do want to write some things down about, and this is called the common logarithm, and it's a logarithm with base 10. And notice they wrote it here as log base 10, but really it is written without that base written there. So if you just see the word log, you know it's a log base 10 logarithm. So the function y equals log of x is the inverse of y equals 10 to the x. And you know, you want to know what that log base 10 logarithm is. And this is the one that you can use the log key for your calculator. And sometimes they will ask you to do that, and then it's just a number crunching thing. So just this is what you're writing for these, and you'll notice there's a pattern here, right? From, you know, any base to base 10. So I'm just going to go through why all these works. The log of 1 equals 0, and this is the unseen 10. So I don't know if I can use the magic pen or not. So there's like a little 10 there. Yeah, it's gonna. No. Well, I kind of have something going on there. Okay, it's not, no. Huh, I expected it to do something there. But that's okay. So let me make sure I'm not using that anymore. Okay. Um, so then the x base is 10. Oh, great. Now I have no marker anymore. Yeah, it's not happening. So let's just try, you know, we'll try one more time. Maybe I'll be lucky and all that's really well. Okay, so I'll just say it then. 10 to the 0 is equal to 1. And so we already said that a minute ago. Let me see. Here's my kind of technological thing. I'll just go to a different. Oh, yeah, look, see, it works there. And now when I come back, maybe it will. Oh, of course not. So because I have this little flickering hand that kind of makes me feel a little unsure of what's happening there. So I'll see if I can write with the mouse. So be ready for this because this will be entertaining. No, see that? It's not even giving me the pen. So, well, there's the basic properties. Did you write them down yet? Okay, perfect. So here's what you're going to do. The log of 10,000. Write it in exponential form and then figure out what it is. And what's the base? 10. Oh, yeah, please don't shout out. Yeah. Okay. Oh, there we go. So the log, I'll just try this one here. The log of 10,000, I'm on track here, equals 10 to the, and I'll write that as equals x. So that means 10 because that's what the base is there, even though it's not written. So I'm going to get rid of that. 10 to the x equals 10,000. And we, there we go. So that is 10 to the x equals 10,000 is 10 to the fourth. How do you know it's 10 to the fourth without doing any arithmetic? Oh, without putting in your calculator. There's 4 zeros, so it's 10 to the fourth. And so x equals 4. Oh, I am so on track. There we go. I know, I'm coming over there for the next one. Okay, here's the next one. Don't shout out the answer. Are we ready? Okay, now you can say the answer. What is it? 12. 12. Yep. Right. And we haven't really talked about that yet, but we will on Monday. Okay. And I'll talk about that. But today I wanted to just kind of do this, and we're missing people, and that's something I want kind of everybody to be here for. So the log, or 10 to the log of 12, means that this is the log base 10. And so if I let it equal p, so the log base 10 of p equals the log of 12. So p equals 12. Are you getting the idea? All right, perfect. Oh, just a sec.